Hello everyone, and welcome to Jumperman Tech, where we specialize in HVAC, do everything DIY, and today we have a service call for a 2-pipe fan coil unit. Thank you to everyone tuning into Jumperman Tech. Today we have a service call for a 2-pipe fan coil unit. It is a nice chilly day here in New York City. Let's go ahead and see what's going on. Alright, so I got a complaint that we are not getting good heat. So let's go ahead and take off this panel. Okay, so we have the system on off currently. Here's the control panel. It's just a huge mess. Christian, let's put the system on heat. I want to see which really lights up. All right. Fan started. This one is cooling. Just like to label those. If you guys watched my previous videos, you know that we have an electric heater in here. Since we're still in cooling season and the pipe is cold, the auto changeover switch is sensing, hey, the pipe is cold, we can't open the actuator, because if we do, we're gonna actually get cooling. It senses that the pipe is cold and redirects the voltage to this relay here to energize the coil, 120 volt coil. And that will essentially turn on a set of electrical heaters. When they switch the water to hot water, the auto changeover switch is going to sense, hey, the water is hot, now we can open up the actuator. But we're in this tricky mid-season, so there's two sides to a relay. There's two connections here, two terminals, which represents the coil. When that coil is energized with 120 volts, an electric and magnetic field is created. An electromagnetic it's either going to open or close a set of contacts. In this case, we only have a set of normally open contacts. Once the coil is energized, we're going to have an electric magnetic field, and we're going to close these contacts. First, let's see if this relay is energized. Let's check between the coil. We don't have voltage, so we don't waste time troubleshooting if this heater is not even good. What I'm going to do is I'm going to take a jumper cable and put a jumper across the contacts, the normally open contacts. Man, it's freaking tight in here. All right, let's get this jumper in here. One there. And the next one up here. Okay. As soon as I turn on the power, we should get amps. I'm gonna do a quick test. 8.7 amps. That heater works. Power is back off. Okay, that's good. I still don't know if the relay is good, but the heater is good. I have relays and everything else we need. The tricky part is that heater. Okay. Here we have the auto changeover switches. They are sensing the pipe temperature. Some people call them pipe sensors, and sometimes I do too. Let's look into this wiring. All right, guys, makes it hard to see, and also the space is super tight. It makes it hard to troubleshoot. We have one auto changeover switch here, one auto changeover switch here. There's 3 wires on them. There's a blue, a white, and a red. Red should be common. As far as this control, they're all different. I know that red is common. That's where power usually comes in after this relay. If the pipe is hot, I believe it comes out of blue. If the pipe is cold, it comes out of white. When I noticed is, so look right here. This common is wired properly. So this yellow wire is the thermostat, sends power into here, and the white and black, which over here, the white and black is energized, which signifies cooling. Here's the cooling. And then the coil input is white and black for 120, and then white and yellow is a common. So that's why this lights up when we get called for cooling. Sends power through the yellow wire from the thermostat. Then it goes to the white and black, energizes this coil, opens or closes a set of points in here. But what we're paying attention to is here, it comes in through the red, common, with this one. So this is the one for cooling. Let's look into the heating one. And I looked into it, and it's the brown wire from the thermostat, this guy right here. And what's happening, it comes in right here, energizes the white and red, which corresponds with the heat relay here, number 2. This light represents number 2, this light represents number 1. White and red is your 120, then white and purple is your common. So this does energize. So this thermostat is working, turns on the fan, and sends power here. We can tell because we know that light is energizing. When that light is energized, we know the coil is energized. But look, it doesn't even go through the pipe sensor. It doesn't go through the pipe sensor. This thing is not even wired. What is going on here? You can see, look, this red has 3 wires in it. The yellow from the thermostat, this one right here. The yellow from the thermostat, the white and black for the coil of the relay, and then it goes into common. So that one, this is the one for cooling. Let's focus on this one for the heating. What's supposed to happen is the red on this auto changeover switch pipe sensor should be connected here. The red, but the red here goes straight to the actuator. That's really weird. All right, go straight to the actuator. Oh, what? And then the white goes to the white goes to the relay. That is correct. We have a mix-up where the red really should go here, the coil from the thermostat, and then the wire for the actuator, if it senses the pipe is cold, right, it goes into there, correct? But then if it senses that it's hot, it should go into blue and energize the actuator. We need to rewire this. But even then, why is this? I gotta look into how this is wired as well. I am seriously confused with what is happening here. It really doesn't even make sense. It seriously doesn't. So I'm gonna have to redo all this. This right here, this coil for heat, should go into the red. So we should put those together, but then this actuator wire should go on the blue, and this stays. So the pipe is cold, it's gonna go through white to the electrical heater relay, which is correct. And if the pipe is hot, it's gonna go through the blue, which then should get connected to this black wire, which is one side of our actuator motor. Let's test that. Hopefully that sensor's even good. And then also double check that the cooling is working. Right now the cooling is working, and I'm telling you right now, I don't understand how. We gotta see what's going on, because cooling comes in through here, right? Goes into the red. And right now, there's nothing connected to blue, so there's nothing there. But then it comes out white and then goes right back into the other, goes into the other auto changeover switch, which I don't understand. Let me switch this. Let me switch it to, let's stick with heating right now. Let's focus on heating. Power's off. Let's do this. Just by, okay, the actuator, I can leave that disconnected right now. If I just put this together, because the pipe is cold, it will come out, it'll go through the red, and out through the white. So this should essentially turn on that electrical heater. And then we're gonna have to make sure that when the water switches, that it's actually gonna work. When the water switches, it's going to actually work to energize that actuator. But right now, comes in through the red, out through the light, and it should energize this relay. It should energize the relay. We got nothing happening. Let's go ahead and turn the thermostat back to heat. You might need to reset that. Oh. All right, so the system is on heat. That relay did engage, so the relay we know is good. We know the heater is good. The heater is on, but look, now heating and cooling is calling. Is this actuator open? The actuator is closed. So we do have heat. I'm telling you, this thing is wired wrong, man. This thing is wired wrong. Should not have both of these. Look, heating and cooling is on right now, but we do have heat. Let's check temperature at least. Here's the supply air grill. Got 85.3, 0.5, so it's rising, and we got pretty good temperatures. This thing doesn't really get that hot, but it's climbing and it's doing its thing. Still, why is both relays lit? That's strange. It's rising, 85.8. Why are both relays lit? Somebody wired this thing wrong. Somebody was messing around here and wired this thing wrong. Christian, let's put the system on cooling. Let's see what happens. Cooling is on. Both relays are energized still. Heater is on. And now the actuator doesn't, now the cooling doesn't even work. This whole thing is jacked up. All right, guys. This thing is all wired wrong. This is gonna be tricky. We're gonna have to rewire this whole thing. Unreal. And how was the cooling even working before connected over there? It was going through the other switch, and somebody was just messing around with it, and they just happened to get it to work with whatever was happening. There's a good chance one of those auto changeover switches is actually bad sending power. So thing is, I don't understand, why is there two switches? In all honesty, we don't need two of them. If it's cooling, the only thing it would do is open that actuator or not. Look, they even have this one wire disconnected. It's like, why do you even need to go through the second auto changeover switch? At this point, with this freaking mess over here, I'm getting rid of that. And that's it. I am getting rid of it. We're getting rid of that auto changeover switch. Calls for cooling, go straight to the actuator, 120 volts, out of the actuator, back to neutral. Done. Next we have already we have the next wire, heating comes in, goes into red like we have now. The pipe is cold, goes through the white to that relay, and then the blue, if it's the pipe is hot, it's gonna go to the actuator. And that's it. That's what we're gonna do. I'm gonna start with this to see if that thing is even good, but I think one of them is definitely bad. Or at this point, maybe it's just better to give them a whole new switch, and we're gonna redo it. I think that might be the better option. Also, let's make a little money here with this hack job of a repair, whoever was here last. I have a diagram here, but I'm not even gonna look at that. I just need to know, it says right here, red and black opens at 85 degrees, red and brown opens at 70 degrees. Clearly common is red here, and either black or brown is for heating or cooling. Power's now off. I'm gonna redo this whole thing. This thing is out. Let's bring these switches down so I can really focus and see what the heck did they do here. Now let's cut this out the way. Bring that down. This thing doesn't make sense, man. This is seriously bugged out. Alright, as far as cooling, hold on, let's keep this like this. As far as cooling, it's this yellow wire. Goes in through here. The neutral already goes back to neutral for that actuator. Let's disconnect this pipe sensor. We don't need this thing, man. Seriously, we don't need this. And it goes through this, and that's why both of them are energizing. Keep it simple, man. Keep things simple. I don't know why they do all this nonsense. So the yellow wire from the thermostat. I guess I could leave the coil wire for this relay there too. Why not? And then the actuator wire right here. So right there. As soon as you call for cooling, as soon as you call for cooling, it's gonna energize the actuator. You should get cooling. Cooling down to 59, cool on. See, only one light is on now, so we're sticking with that concept. And I can hear the water moving. Let me just put my hand above. Yeah, there we go. Cooling is on. Let's check this. You guys can see 63, 62, and dropping 61. Yep. Cooling is now working. Come on. Let's keep it simple. Let's keep it simple, guys. All right, next we have to worry about that next. We have to go through the auto changeover switch for the heating, because when the water's cold, it has to energize the electrical relay for the electrical heaters. When the water is hot, it's supposed to open up the actuator so we can let the water flow. And there we go, get our fan coil. You know, we got 57 degrees. Cooling is done. Turn the power off, everything de-energized, and this is a spring return actuator. I heard the water just spring back because it lost the power, and I don't hear any water squeezing through. We should be okay. Why do you need an auto changeover switch? You're not even using it. Like, you're not really using the purpose of this switch. So this thing goes back to the museum. That old control goes back, goes to the museum. Gone. We don't need that. Now, let me just test something. Now, The heat should work for electrical because I have that wired. We might need to disengage this, possibly. So we call for heat that goes into the pipe sensor through red. If it's hot, it goes through here, which is good. And then if it's cold, it goes through here to energize the heating relay for electrical heater. And if it's hot, it should send power to the actuator. The only thing is I don't want to send a feedback. This might be a problem. Because I might send power back to the cooling wire in the thermostat. I might blow this thing. Maybe that's why they did that. Let me think about this. All right, I thought about it. We might get some feedback if we do it like that. If I just have this connected, I don't think it'll really be a problem. I don't know if I want to risk it. But I was just testing these auto changeover switches. So check it out. I got it on continuity right now. I know red is common. And let's check to see which one is making continuity. Not brown, but black is. This one is good. Let's check this one. Red, unless I wasn't touching, which I'm pretty sure I was. And black should be touching. I got nothing. And brown, nothing. This switch is freaking bad, man. Unreal. It's bad. Let's check this one. Are these touching? At least for cooling? Because then I'll just have to reuse this. It is. This thing is coming back from the museum, back to the unit. This thing is coming back to the unit, man. I can't believe it. Unreal. All right, I gotta figure this all out. This is gonna be really, really tricky. I don't know why all this extra stuff is here. Let's try to stick with what they had because that concept worked. I'm gonna try to go based off that concept, but still I'm gonna have to rewire it in my way because of that. Problem is, man, there's no wiring diagrams on these units. There might be a wiring diagram actually on the blower. Sometimes it's weird. I know it sounds strange, but on the blower motor's casing, the housing, I think there might be a diagram there. I know it's strange. Why do you do this, McCoy? Why? Okay, so I wired it. This one is for cooling. This one is for heating. We'll see it from underneath. So now, cooling wire sends power from the yellow, energizes this white and black, which should energize the light on this relay, the coil. Then it goes into red. Nothing happens in blue. Comes out of the white and energizes the actuator. This is the hotline for the actuator. Then the heating one, which is this one, comes through the brown, energizes the white and red, energizes the light here, goes in through red common. If the pipe is cold, which right now it is, it's gonna come out here and energize this wire, right, which energizes the heat relay to energize the electrical heater, as it should. And then if the pipe is hot, it's going to come out through this blue wire and then energize this black wire, which is our actuator wire. And because of the temperature, these would switch and not cause any feedback. And I think that's what's going on here. Right now, at room temperature or on the pipe, regardless, it should send power between red and white, and then red and white. So it's not gonna make a difference if they're just hanging there as far as right now, while I'm testing. And in the meantime as well, I'm seeing wires like this from this relay, which do have voltage on it. This will short out. And then other connections like the fan motor, look, these guys just taped this up. I mean, they changed the motor, they didn't even put a wire nut, they just put some tape on it, and they're like, you know what? Fixed! So right now, it should be wired right. The only thing is we're gonna have to test this heating one. I'm gonna heat it up with hot water or like a lighter and make sure it switches over and opens up the actuator. But as of right now, I believe this should work. Let's put the system on heat. Raise the temperature above the room. No lights are on the relay. Oof, both of them are on. Both of them are on. Okay. That's telling me right now that one of those, that the heat, the heat auto changeover switch is bad. Let's change it with the one that's actually good. Oh boy, because we shouldn't be energizing both. Okay guys, I wired this one and we got that original. This is the cooling one for original and the new heating one. So right now I got the system on cooling. Only the cooling light is on. We're not pulling amps on the electrical heater. And we got 55.6 degrees. Only one light is on that relay. Before both of them were energizing. Now let's go to heat. And raise the thermostat. We got no light on the relay because we're satisfied. And you see now only one light for the heat is on, correct? Now we got amps on the electrical heater. And I don't hear water squeezing through. You could also check on this kind of actuator on top, the stem. And I can see the stem is closed, so now it's doing its thing. It's gonna take a little time for this heater to do its thing, but we know that the actuator closes. You can see temperature is rising, 67.3, 0.5, 68. Let's see what happens. All right guys, got 85.3 degrees and rising. So the heating and cooling work according to the pipe temperature right now. One thing we're gonna have to check is to make sure that when we heat up the auto changeover switch that I just installed, when we heat that up, when it senses that the pipe is hot, it should turn off the electrical heater, and what it should do is energize the actuator. In this case, we'll get cooling, but this is gonna be a test. This water is super hot, so I'm gonna use the water. I have a lighter, but I don't wanna burn the thing. And at the same time, it's not good to mix water with electrical, but we're only gonna put it on the part where it senses temperature and just not go too deep into the water. Man, look at the color of that water, man, it looks like milk. All right, we got the hot water. Let's keep that on there. Right there. I see that the amps turned off, and I heard the actuator open. Perfect, so it's switched automatically based on temperature. It's lighting up both, but that's because I'm doing something strange. Shouldn't do this. Make sure that it's open. Yep, valve is open. Valve is open. All right, now we got some cold water. Let's make sure it switches back. This should energize the electrical heater. Okay, it just switched. I thought I fried this thing for a second. All right, heat is back on. Electrical heater, since the pipe is cold. Only the heat relay is on. And the valve is closed. All right, it's doing its thing. It's changing automatically based on pipe temperature. both lights came on at that moment, because what would happen is that the cooling auto changeover switch would sense that it's hot, and it would no longer send voltage to energize the cooling here. And then the heating would switch over from turning on the electrical heater and open the actuator. You know, we would have 2 switches at a time, but I was only holding the water on 1 switch. They would both switch simultaneously. So that's what happened there. But it looks like we're good to go. Let's close this all up. All right. Close everything up. And I tested it once again. That's a pro tip right there. Even though you fix the machine and you got it working, when you're dealing with a tight electrical panel such as this one, when you put the wires back, something could get loose or disconnected. So after you bunch everything back and close up the panel, I would do just a quick test, check the heating and cooling, throw a thermometer in the duct, make sure it's doing its thing and nothing shorts out or whatever. Just make sure that it's working well. Also, another thing is always make sure that the filter is clean. The filter is clean and we are good to go. We're gonna wrap it up from here. If anyone found this video interesting or helpful, please drop a like, comment, and subscribe as I come out with new videos every week. And I'll catch you all next time.